back to another session. We are going to continue with compound interest, and we're going to look at now the compound interest formula so that you can be able to make our work a bit easier when you're dealing with the questions concerning the compound interest. Let's have a scenario here. You have, let's suppose that we have P shillings invested at R% per period compounded interest. The accumulated amount after n interest period can be calculated as follow. Let's see how we can be able to get the accumulated amount after particular number of periods. So here, the first interest period, we are going to have interest will be T over 100. Our principal is P shillings times rate, which is R. Time is usually 1, so you don't have to write that, over 100. So that is the interest in the first period. Then the amount after the first period will be the principal that we had, the first principal there. Then we add the interest, PR over 100. And in this case, we can factor out P. We'll be left with 1 plus R over 100. So that is the amount after the first interest period. Let's see the second interest period. Second interest period. So our second interest period is going to be the principal, which is now P to bracket 1 plus R over 100. So second interest period, you're going to have PRT over 100. So principal now is going to be P into bracket 1 plus R over 100. Then we multiply by rate over 100. Of course, time is usually 1 because we are calculating this per period. And then in this case, we can have it, that is our interest in the second period. So the amount here in the after second interest period is going to be now the previous principal, which is now P into bracket 1 plus R over 100. This one, we add the interest in the second period, which is now P into bracket 1 plus R over 100, and then times R over 100. So this is our second amount, and we can be able to see that P plus 1 R over 100 and the P into bracket 1 plus R over 100 is common. We can factor it out, and when you remove it, you're going to be left with, we remove P, 1 plus R over 100. You're going to be left with, in this case, we're going to be having 1 plus this addition. When we remove this one, you're going to be left with R over 100. Going to be left with R over 100. And then this is our amount in the second period, so you can be able to see that P times 1 plus R over 100 times 1 plus R over 100. This is they are the same, meaning we can say this is 1 plus R over 100 squared. So this is P to bracket 1 plus R over 100 squared. So that is the amount from our second period. Then we look at the third period, third interest period. We are going to have now interest is going to be PRT over 100, and then our P is now this second amount in the second period, which is P into bracket 1 plus R over 100 power 2 times rate over 100. So that is our third interest. Then we get the amount after the third period. We are going to have amount going to be the principal, which is now this one, the new principal there, P into bracket 1 plus R over 100 squared. We add the new interest. Our new interest here is this, everything here, P into bracket 1 plus R over 100 squared times R over 100. And when you look at these two, you can be able to see that 1 P into bracket 1 plus R over 100 squared is common in the two terms. So we factor it out just as our previous case there. So P into bracket 1 plus R over 100 squared, we factor it out, we remove it, and then you're going to be left with, then when you divide this by this, of course you're going to be left with 1. When you divide this term here by P plus 1, P into bracket 1 plus R of 100 squared, you're going to be left with now plus, you're going to be left with R over 100. And of course, you can be able to see that this is now R plus 1 plus R of 100 squared times 1 plus R of 100 squared. So this term is the same. So here, you can be able to see that now we can simplify it further here. We say this is P to bracket now 1 plus R of 100 squared, then times 1 plus R of 100. That of course we're going to be having now 1 plus R over 100 cubed, because just like you have a number like 2 squared times 2. You're going to have this is 2 cubed. The same case here, you're going to have it as a P is equals into bracket 1 plus R of 100 cubed. And if you can be able to observe well, when in our first interest period, the amount was P into bracket 1 plus R over 100. Then the second interest period amount, we had P into bracket 1 plus R of 100 squared. Then the third interest period here, we have P into bracket 1 plus R of 100 cubed. Meaning now, we raise the power according to the number of terms. If it is the first period, the power is 1. If it is the second interest period, the amount is going to be given by, of course, the power is going to be 2 there. So here, in any case, we have n times. We have n times. Like 10, 15 or so. Then the amount is going to be given by P into bracket 1 plus R over 100 power n. This n can be 1, 2, 3, or so on. So if it is 5 times, then the n is going to be, of course, be 5. That is a compound interest formula. So we are going to have some examples. We can be able to practice on how do we use the compound interest formula. So let's look at example 1. This is how we can be able to use the compound interest formula. I have, what would 15,000 shillings amount to after 3 years at 16% per annum compounded quarterly? So we have the initial amount here is 15,000, and then the rate per annum is 16% per annum, and we have the time is 3 years. our amount here, our interest, our principal here is going to be compounded quarterly. What does it mean? That in 1 year, how many quarters do we have? We have 4 of them. So that is what you need to understand. So here, the first thing to get is the rate per period. So the rate here per annum is 16%, but you have this is per annum. In that 1 year, we are going to compound our amount 4 times because it is compounded quarterly. So our rate, we said, is going to be 16 over the number of times, which is 4, and we are going to get 4% per period. Then, because now our time is 3 years, and in 1 year we have 4 periods, so our n, the number of times we are going to be having now, the 3 times 4, we get 12 periods, because in 1 year we have 3 in 1 year we have 4 periods. So in 3 years we are going to be having the 12 number of times that we are going to compound our amount. And then when you have that information, and getting the amount after that is very simple. We apply a formula. Amount is given by principal in the bracket 1 plus r over 100 power n, and in this case our principal here is 15,000 into bracket 1 plus rate per period is 4 over 100 times power n. We are going to be having 12 times. That's how we're going to compound our rate here. So you have 15,000 into bracket 1 plus 4 over 100. 4 over 100 is 0.04. So this is going to be 1.04 power 12. And multiply that, we are going to have the 15,000. We multiply by 1.04 power 12 is going to be 1.60103. 1.60103. Then we multiply by 15,000. We get approximately 24,015. 24,015.5. That's approximation about value there. That's the amount that we are going to get from 15,000 compounded 60% per annum for 3 years, compounded quarterly, meaning in every quarter we are going to have, in every year we are going to have 4 periods or 4 quarters. That's the amount we are going to get after the 3 years. That is how we go about using the compound interest formula. Let's look at example 2. I see how I can be able to get this. We have the question here. Find the time taken for accumulated amount of 17,908 shillings from a principal of 10,000 at a rate of 12% compounded semi-annually. In this case, you have been given the accumulated amount is 17,908. Then from the principal, which is 10,000, and you also been told that the rate is 12% per annum. Rate 12% per annum, and it is compounded semi-annually. So here we need to get, we have the amount is 17,908. The principal is 10,000. The rate is that. We need to get the time, find the time taken. Now the first thing here is to know that our rate is per annum, and we compound this amount, the principal, in semi-annually. Meaning now, our rate that you're going to use there is going to be 12 divided by 2 semi-annually. In 1 year, you have going to have 2, and then this is going to be 6% per period. So in 1 period, you're going to have a 6%. Now, we also need to know that time is going to be in years here, and then you have n, which is going to be in 1 year you have 2. In 1 year you have 2 period. So we are first going to get the period, then you go backward to the years. So we use the formula. Amount is given by principal bracket 1 plus r over 100 power n. Amount here, we have 17,908 is going to be, principal is 10,000 into bracket 1 plus. Our rate is 6% per period, power n. We are going to find that n. So we can divide by 10,000 on both sides. We have 1, 2, 3, 4, 1, 2, 3, 4. 1.7908 is going to be, then 1 plus 6 over 100, 6 over 100 is 0.06, so this is going to be 1.06 power n. So you're going to have it like that. Then here, of course, we need to get the value of n. So we are going to introduce log on both sides. We have the log of 1.7908 is equals to the log of 1.06 power n. Then, when you have a log of a number per something, this number you can drop it to this point. So here you're going to have log 1.7908 is equals to n, the log of 1.06. And of course, to get n, we are going to have, we divide both sides by log 1.06. We divide both sides by log 1.06. So our n there, we are going to have it as now, this is going to cancel. Log 1.7908 divided by log 1.06. And that one, I have 10.00, 10.06, which is approximate 10. So that is the number of period that we have. Remember, in 1 year, we have 2 periods. So if we have 10 periods, meaning that we have how many years? We have 10 periods, meaning that now we have 5 years. So we divide this one by 2 to get 5 years, because in 1 year, we did compound semi-annually, meaning that in 1 year, we are going to have 2 periods. So if you have 10 periods, then going backward to the years, we divide by 2, we get 5 years. That's how we'll be able to answer that kind of a question. Let's have example 3. So example 3, we have a farmer invested 48,000 for 5 years. Calculate the rate per annum of compound interest if the accumulated amount was 77,304 shillings 0.5. So in this case, you have the principal, you have the amount, we have the time, we need to get the rate. So we've got amount is 77,304.5. The principal that was invested was 48,000. And then the time, we have 5 years. So we need to get the rate. So you just use the formula. Amount is given by P1 plus R over 100 power n. So amount is 77 304.5 is equals to the principal, which is 48,000 into bracket 1 plus R over 100 power 5. So here we can divide both sides by 48,000, so that you can have this case here going to be left with 1 plus R over 100 power 5. Then 77,304.5 divided by 48,000, I have 1.61015. 1.61015. That is when we divide 77,000 by 48,000. Then we have it like that. We have this is power 5, this is like that. Huh? To remove this power 5, we find fifth root on both sides. We find fifth root on both sides. And then we are going to have, this is going to be left with 1 plus R over 100. Fifth root of that number. And then fifth root of 1.61015, I can use your calculator there. I have 1.1. 1.1. That is the fifth root of that 1.61015. So here I can take this on the other side. I have 1.1. This is plus. On the other side is going to be minus. 1 is going to be R over 100. And then this is going to be 1.1 minus 1 is 0.1 is going to be R over 100. And then when I cross multiply, I have R over 100 is equals to 0.1. So I can cross multiply. I have R will be 0.1 times 100, and this is going to be 10%. That is how you can be able to get the rate being provided with the other values there. Let's look at now our last example. Example 4. It reads, a farmer wants to accumulate 400,000 in 5 years. How much money must he invest now at 10% per annum? So we have a farmer here who wants to accumulate amount of 400,000. So the amount here we want to accumulate is 400,000. Then in 5 years, time 5 years, and then the rate is provided as 10% per annum. So we are being asked, a farmer wants to accumulate amount of 400,000 in 5 years. How much money must he invest now at 10% per annum? So we want to find the principal there. So here you get the formula. Amount is given by P1 plus R over 100 power n. So that is the compound interest formula. So amount we have 400,000 is going to be principal, we don't know, 1 plus rate 10 over 100 power n 5 years. So here you get 400,000 into bracket P 1 10 over 100 going to be left with 0.1, so that is 1.1 power 5. So now we have the 400,000 is going to be P times 1.1 power 5 is 1.61015. And multiply that one, of course, I'm going to get 1.61015p. So this is going to be equals to 400,000. So of course, 400,000 is going to be 1.61015p. I want to get the value of p. I divide by 1.6115 on both sides, so that I can do it with the p there. It's going to be 400,000 divided by 1.61, so 15. I have 248,000. 368,368.50 approximate. So the amount that this person can invest now is approximately 248,368.50. That is the amount that this person can invest, that in 5 years time is going to be 400,000. Thank you very much for your time.